exterior, and then we have to check. We have to deal with the endpoints, what's called the boundary. Okay. So what happens on the boundary? Well, right. And you see that this is centered at -2, right? Because this is x minus -2 to the n. Right. The center is -2. Right. The center is -2. Okay. So what happens at the endpoints, right? Well, when x is 1, you're going to get summation -1 to the 3 times 3 to the n squared, 3 to the n, right? N equals 1 to infinity. Does it converge? Does it converge? There's an n here. It doesn't matter. Does it converge? Yes or no? You should be able to tell me pretty quickly. The 3 to the n's cancel, right? You get summation -1 to the n over n squared, n from 1 to infinity. Converge? Yeah, right? Converge because? Okay, who can tell me, who can say why it converges? Who can give a reason? Who can give an argument why this converges? Because you have a 2 here, right? It's n squared, and you know that if we take the absolute value, then this is summation 1 over n squared, and that converges. If that converges, then that converges, right? Absolute convergence forces convergence, right? So this thing converges. In fact, it converges absolutely. Okay, so at 1, we're good, right? So I can fill in this point here. Okay, what about at -5? At -5, I'm going to get, so I'm going to get a -3, right? So I get -1 to the n, -3 to the n over 3 to the n squared summation. Right? So I'm going to get I just get a 1, right? I get -1 to the n. I get another -1 to the n. And then I have an n squared. Right? Because this -3 to the n over the 3 to the n become a -1 to the n. Right? But I've got, that's -1 to the n times -1 to the n, so that's just 1, right? That becomes 1. Right? Now we're back in the summation 1 over n squared. We know that converges. It converges, right? So, in fact, we have the full, in fact, we have both endpoints. So the domain of convergence is the closed interval of -5, 1. Okay. Okay. Let me just do one. Let's put up one last example here. Let's say 2 to the k factorial over 3 to the k. I'm sorry, 2k factorial over 3k factorial x to the k. Okay, let's get started on it. So what test are we going to use? Ratio test, right? You're not going to use the root test because they're always factorials, right? So say, okay, let's take the limit as k goes to infinity of the ratio of the absolute values, right? So we get 2k plus 1 factorial over 3k plus 1 factorial x to the k plus 1, absolute value of x to the k plus 1. We have 2k factorial over 3k factorial, absolute value of x to the k. Right? Okay. And what happens? You see that you're going to end up with, this is 2k plus 2, 2k plus 1, and then 2k factorial. This guy is 3k plus 3, 3k plus 2, 3k plus 1, 3k factorial. Right? And we have x to the k plus 1 divided by absolute value of x to the k. And we also have a 3k factorial, and we have a 2k factorial. We take the limit as k goes to infinity. Right? Okay, everybody get that? Okay, so what happens, right? 3k, 3k, 2k, 2k, right? We end up with this thing, right? 2k plus 2, 2k plus 1, over 3k plus 3, 3k plus 2, 3k plus 1, x to the 1 as k goes to infinity. Right? But what happens to that? What is that? Go ahead, Jungle. Yeah, 0, right? You always get 0. Equals 0 for all x. Right? No matter what x you put in here, as k goes to infinity, you've got basically k squared over k cubed. Right? K squared, you've got basically k squared over k cubed times the absolute value of x. But that's going to go to 0. That's always going to go to 0. So what does that tell you? That tells you that this thing converges everywhere, right? Because for the ratio, what the ratio test says is that if the ratio is smaller than 1, you have convergence. And this, what we find out is that for any x, you get 0. 0 is always, for whatever number you put in here, you get something smaller than 1, right? So this series is going to converge on the whole line. So this converges on all of R. Okay. Anyone have questions? Shipin, it looks like you have a question. No? Okay. Take a very, very, very short break, okay? Like 3 minutes, and then we're going to get started again.